You know that feeling of a brand new t-shirt? That perfectly smooth, clean finish? Well, ever wonder how it gets that way? Turns out the answer is a lot more dramatic and a lot more fiery than you'd ever imagine. It's a hidden step in manufacturing that makes all the difference.
So, here's what we're going to cover. First, we'll talk about the main villain of our story, fabric fuzz. Then, we'll meet the wild, unlikely hero, fire, and break down exactly how this whole thing works. We'll check out the machines built for this fiery job, and finally, we'll get into the super high stakes of, well, literally playing with fire.
All right, let's kick things off with the problem itself. Fuzz. You know, that little bit of fluff on your clothes? It seems so harmless, right? But in the world of textiles, it is a massive, massive issue.
You've totally seen this before, right? You're looking at two shirts that should be the same, but one just looks better, crisper, higher quality. That difference, a lot of the time, comes down to these teeny tiny, almost invisible stray fibers sticking out all over the place.
And these little fibers, they cause a whole bunch of problems. It's not just that they look kind of fuzzy. They actually make printed graphics on your shirt look blurry. Over time, they tangle up and form those annoying little balls we call pills. A fuzzy shirt even gets dirty faster, and it loses that nice smooth sheen. So, bottom line, if you want quality fabric, those little fibers have got to go.
So the big question is, how do you get rid of all this fuzz on an industrial scale? The solution is, well, it's pretty wild, and honestly, it's a little bit terrifying.
Yep, you heard me. You take a perfectly good piece of fabric and you set it on fire. I know, it sounds completely bonkers, but this is one of the most important steps in making the clothes we wear every day.
This crazy process has a name. It's called singeing. The whole idea isn't to burn the fabric itself, but to just scorch the surface. It's like giving the fabric a super close shave, but with an open flame. You burn off only those tiny fibers sticking out, which creates a perfect, clean slate for all the dyeing and printing that comes later.
Now, obviously, you can't just take a blowtorch to a bolt of fabric and hope for the best. This whole thing is an incredibly precise, super high-speed industrial process. Think of it like a carefully choreographed, three-step dance between the fabric and the flame.
It all happens in the blink of an eye. First, the fabric gets brushed, which makes all those little fuzzy fibers stand up straight. Then, the main event. The fabric literally flies over an open gas flame at insane speeds. We're talking hundreds and hundreds of yards per minute. The speed is the whole secret. It's just fast enough to zap the tiny fibers without harming the fabric. And finally, boom, it's plunged straight into water to kill any sparks. Brush, burn, bathe. It's that quick.
Now, to pull off this dance with fire safely and get it right every single time, you need some seriously specialized gear. In the textile industry, there are three main types of machines that do this job.
And while they all have their uses, one method has pretty much become the king of the castle. It's the most effective, the most versatile, and it's the one you'll find in most modern factories.
So let's break it down. You've got plate and roller singeing. Think of them like a giant super hot iron. They work, but they're kind of slow, and the heat can be a bit uneven. But then you have gas singeing, which uses a direct flame, and this one is the real deal. Just look at the speed. We're talking up to 400 yards a minute. You get perfect, uniform heat, you can singe both sides of the fabric at once, and it works on pretty much anything. It's no wonder it's the industry standard.
Okay, but as you can probably guess, when your job is to run fabric over an open flame at the speed of a race car, things have to be absolutely perfect. The line between a flawless piece of cloth and a completely worthless burnt roll is razor thin.
Take a look at this number, 75%. Just let that sink in for a second. This number shows you just how badly things can go wrong.
So what does that mean? It means if your speed is off, if the flame is just a little too high, if there's a damp spot on the fabric, you can destroy its strength. A 75% loss means you've created a fabric that you could literally just pull apart with your hands. It is totally, completely ruined.
And there are so many ways for it to go sideways. Not enough flame, and you've still got fuzz. Too much flame, and you've just damaged $1,000 of fabric. If the fabric is damp, you'll get blotchy spots later. If a single gas jet is clogged, you can get stripes. And if you're working with something synthetic, you can accidentally melt the fibers into tiny, hard plastic beads. It's a constant, high-stakes balancing act.
The level of precision here is just incredible. The machine operators are so skilled, they can actually read the color of the flame to know the exact temperature. They're managing ventilation, speed, tension, all while making sure the fabric is quenched in the blink of an eye. This isn't just brute force, it's a split-second science.
So the next time you pull on a nice, smooth shirt, you'll know its secret. It probably went through a literal trial by fire just to look that good. It really makes you wonder, doesn't it? What other crazy, high-stakes processes are hidden inside the everyday things we use without a second thought?